Hi viewers, welcome back to my channel. So this is a set of lectures where I solved examples from the topic of bolted joints, a very relevant topic. That's why I'm taking the effort to do solve problems here. Without much ado, let's get to the first problem. So the first question is like this. Compare the tensile load capability of an M8 1.25 and M8 1 ISO threads. So there was a set of lectures where I talked about the introduction to thread profile. So this is your nominal diameter and this is the pitch, and this is how metric threads are designated. In the question we are asked to compute the tensile load capability of these two threads. So the first thing we need to find is the stress area corresponding to each of these thread profiles. So here I have shown the stress area corresponding to each of the thread profiles, and as you can see over here, which is the finer among the two, this one or this one? This one is the finer. Why? Because the pitch is small. The distance between adjacent crests and adjacent troughs is called the pitch. So in this scenario, pitch is small here. So that's why for the same nominal diameter, we are having a higher tensile stress area. In case if you have forgot what is tensile stress area, see, when threaded rods are subjected to pure tensile loading, tensile strength is defined by the average of the root and the pitch diameter as shown over here. So this is the mean or the average of the root and the pitch diameter. And in case if you have forgot what is pitch diameter, minor diameter and all, here I have shown a sketch. So this is your minor diameter. Assume this is your threaded rod. So the tensile stress area is a little more than the area which corresponds to minor diameter. But it is not the one which is corresponding to the major diameter, but it is the average of pitch diameter and the minor diameter. Makes sense? And when this is the pitch, when you have fine pitch, what happens? Your pitch diameter increases and thereby your tensile stress area goes up. I repeat, when you have finer pitch, as per this expression, your pitch diameter is increasing. So as your pitch diameter is increasing, your tensile stress area is also increasing. Make sense? And this D is your major diameter. So once you plug in all these numbers, and if you assume the bolt is made up of 8286, which is having a yield stress of something like 829 Newton per mm square, then the tensile load capability of this particular thread will be this tensile stress area times this value. Similarly here also, this area times 829 will get you the tensile load capability of the thread. So in a nutshell, the finer threads are able to carry more load. Makes sense? So this is a very key concept that we should understand. Before I wind up this video, I would like to add one more point. Fine threads like the one over here are more resistant to loosening from vibrations than coarse threads because of their smaller helix angle, and so they are used in automobiles, aircrafts and other applications because those components will see a lot of vibration. Makes sense? While the coarse threads is most common and is recommended for ordinary applications, especially where repeated insertions and removal of the screw are required. Thanks for watching. This was a very short video, but I wanted to drive home this concept because they can ask you in interviews and all, what happens to the tensile stress area when I have two threads which are of the same nominal diameter, but they are different in the pitch. Which one will have a higher tensile stress area? So you can expect this kind of questions. Thanks for watching.